Modern four-stroke combustion engines are designed to operate within very specific back pressure parameters indicated by the manufacturer. This back pressure value is determined by the force the exhaust gases must exert to overcome the resistance offered by the different internal elements of the exhaust system. It is easy to see that in a conventional exhaust system, the level of back pressure is directly proportional to the amount of gases flowing through it, i.e., when the number of revolutions increases or decreases, so will the exhaust system's level of back pressure. Operating at engine speeds with back pressure values not within the optimum working range brings about a number of problems, including increased fuel consumption and loss of engine power. Whether exhaust gas back pressure is too high or too low, a small amount of fuel and air escapes from the engine's combustion chambers, reducing the power produced within the cylinders. This makes the driver push harder on the accelerator to get the same power, hence increasing fuel consumption. Valve opening and closing times are controlled by the camshaft, a metal part designed by the engine manufacturer to operate at a certain level of back pressure. When the engine runs within this range, maximum engine performance is obtained with minimum energy consumption. The most effective way to optimize engine performance and thus lower fuel consumption of the system is to maintain exhaust gas back pressure values as stable as possible at any engine speed. Recently, some vehicle manufacturers have presented solutions such as engines with selective cylinder deactivation, depending on the load. In these engines, when the vehicle needs little power, i.e. when operating at low speed without accelerating, the system disconnects half the cylinders, thereby reducing the fuel consumption. The partial cylinder disconnection produces back pressure variations which, as we have seen, negatively affect overall engine performance. This situation requires vehicle manufacturers to place larger, heavier, and more complex exhaust systems to minimize these variations. To solve this problem, Tenneco has designed an electronic valve to control back pressure that not only works on vehicles equipped with conventional engines, but does so in a particularly effective way on engines fitted with cylinder deactivation technology. Its operation is very simple. This electronic valve is integrated in the car's exhaust pipe before the rear silencer. The valve is controlled by the car's electronic control unit, ECU. Inside, the valve contains a disc with a central bore rotating on its vertical axis. On turning, the disc opens or closes the flow of exhaust gases, increasing or decreasing the level of back pressure. At low engine speed, the valve will remain closed or almost closed to the flow of the exhaust gases, thereby increasing the back pressure values to optimum performance levels. When the vehicle is running, the valve opens or closes depending on the engine's operating conditions. The disconnection of cylinders, subsequent reconnection, increased speed, etc. will be the conditions which determine how much the valve opens. When the vehicle is operating at increased load conditions, i.e. at high speed and on all cylinders, the flow of the exhaust gases will be maximized, so the valve is completely open to enable the gases to pass with the minimum back pressure. This valve can be used in combination with a second electronic valve in one of the two tailpipes of the vehicle's rear silencer. Because of its location, this valve is known as a TP valve, or an electroacoustic valve for tailpipe sound. The structure and function of this valve is very similar to that previously explained, except that the disc which blocks the exit of the exhaust gases has no hole in its center, i.e., it can, under certain conditions, fully close the flow of exhaust gases out into the atmosphere. The tailpipe valve is also controlled by the electronic control unit, ECU, of the vehicle. This, depending on the engine load condition, opens or closes the central disc to regulate the internal back pressure of the exhaust system, in addition to the noise level of the rear silencer. Its basic operation is simple. At low speed, 0 to 2500 RPM, the back pressure of the system is very low, so the TP valve remains completely closed, helping to increase the back pressure. From 2500 RPM and up to 5500 RPM, the valve begins to open progressively to compensate for the increased back pressure due to the increased amount of gases now flowing through the silencer. This causes the back pressure values to remain more stable during different engine speeds. The use of these valves is not limited to engines with cylinder deactivation technology. They can be fitted to all types of modern engines, both diesel and petrol, with excellent results. This reduces the size of the silencers, and therefore the total weight of the system, resulting in a reduction in fuel consumption and the amount of CO2 gas emitted into the atmosphere. Due to a better back pressure management, the use of these valves increases engine performance at both low and high speeds.
We are Garage Gurus. Join our community. Follow us on social media. Thanks for watching this video. The video description contains all the relevant links. Don't hesitate to like, subscribe, and be notified when we post new content. Also, check out our Garage Gurus online course catalog.